Hello everyone, welcome to my channel C.S.E.Pathshala. We were studying about Python for machine learning and data science, and in this tutorial we will study about NumPy, trigonometric and hyperbolic functions. So let's start with trigonometric functions first. NumPy provides the universal functions like sine, cosine and tan functions that take values in radians and produce the corresponding results for the sine, cosine and the tan values. As we know that we can give angle in the form of degrees also and radians also. Okay, so let's start with our first example where we need to find the sine value for pi by 2. So consider this code and implement it on Jupyter notebook. Okay, import numpy as np, x equal to np.sine. So we are using a universal function sine. Here we are giving np dot pi by 2. So this pi is in radians. Okay, so it's a radian form. And then we need to calculate this value, that is sine np dot pi by 2, and then we are printing the value of x. Okay, so let's save this code and run this code. Okay, so here it is. Its value is 1. Alright, now if you want to give the sine values for all in an array, that means we need to calculate the sine values for all the values in an array. So let's consider a code and then you will understand how to implement this thing. Okay, so here it is. Import numpy as np arr equal to np dot array. So this time we are giving an array of radians. Okay, so arr equal to np dot array, np dot pi by 2, comma np dot pi by 3, pi by 4 and pi by 5. So we can write like this. Okay, and then we will calculate x equal to np dot sine arr. Okay, so there is nothing to enter in a sine like all these array values. It's better just convert this into an numpy array and give array as an argument to sine. Okay, then we are printing the value of x. So let's save this code and run this code. So here it is. The sine values of all the radians which we have given in the array has been calculated. Again in a form of a 1D array, we are printing all the values. Alright. Now if you want to convert degrees into radians, see by default all of the trigonometric functions take radians as a parameter, but still if you want to convert the degrees, or we can say if you want to convert radians to degrees and vice versa, it will be very much easy to perform in NumPy. As we know that there is a formula for this. That means radians values are pi by 180 into degree. Okay, that means radian equal to pi by 180 into degrees, and degree can be equal to radian into 180 by pi. Okay, so let's consider one code and then we will understand. Here we have to convert all the values of the following array into radians. Okay, so here it is. Now import numpy as np arr equal to np dot array 90, 180, 270 and 360. Okay, so these are certainly the values for the numpy array, and then we are performing degree to radian conversion. Here we are having a function or a method to perform this. That means x equal to np dot dg to rad, that means degree to radians. ARR, this is the argument which you are giving to this function, and then we are printing the value of x. So it's a straightforward approach. So let's save this code and run this code. So here it is. Each and every value of numpy array has been converted into radians. Okay. Now if you want to convert radians to degrees, so let's consider one more code converting all the values of the following array ARR to degrees. Okay, so here it is. Okay, import numpy as np arr equal to np dot array, np dot pi by 2, np dot pi, 1.5 into np dot pi and 2 into np dot pi. Okay, so these all values are in radians and we need to convert them into degree. Okay, so again there is a method to perform this, that is x equal to np dot rad to dig. Okay, that means radians to degree, and arr we are giving here it as argument. Okay, and then we are printing the value of x. So let's save this code and run this code. So here it is. These are the degree values for the radian. Okay, now if you want to find angles, for example, finding angles from the values of sine, cosine and tan, example, we need to find that is the sine, cos and tan inverse. Okay, so how to do this? NumPy provide again universal functions, that is arc sine, arc cos and arc tan will produce the radian values for corresponding sine, cos and tan values. Okay, so let's consider an example. We have to find the angle of 1. Okay, so to do this thing, we will write a code. Okay, so here it is. Import NumPy as np, x equal to np dot arc sine or sine inverse, and here we are giving an input as or argument as 1. Okay, so we are calculating the sine inverse of 1, and then we are printing its value. So let's save this code and run this code. So here it is, it's 1.57. okay, now if you want to find the angles of each values in an array, okay, so that's what we need to do. We have been given with the array, and we need to find the value of angles, okay, in arrays. Okay, so this can be done like this. Let's consider a code. So here it is. Import NumPy as np, arr equal to np dot array 1 minus 1 0.1. Okay, so we are giving with the 3 values, and we need to calculate the angles for these. So here we are writing statement again as x equal to np dot arc sine, that is sine inverse for the values of array. Okay, and then we are printing it. So let's save this code and run this code. So here it is. These are respectively the values. Okay. Now, if you want to calculate the hypotenuse, as we know that there is a formula to calculate the hypotenuse using the Pythagoras theorem. So we can also apply the Pythagoras theorem in NumPy. Okay, and in NumPy it provides a predefined function that is called as hypot function that takes the base and the perpendicular values and produces the hypotenuse based on the Pythagoras theorem. Okay, so let's consider a code and then we will understand it and we will find out the hypotenuse. Okay, so here it is. Import NumPy as np, base equal to 3, perpendicular equal to 4. Okay, and then we are applying the formula, that is, then we are applying the method, that is x equal to np dot hypot, base and perpendicular we are giving here as an argument. So it's a predefined method and results will be calculated by it, and we are printing the value of x. So let's save this code and run this code. So here it is. Okay, 5 is the hypotenuse. Alright, now if you talk about hyperbolic functions, till now we have discussed about the trigonometric functions. Now we will study about hyperbolic functions. So the hyperbolic functions are defined through the algebraic expressions actually, and that include the exponential function especially, that is e to the power x, and also the inverse of the exponential function, that is e to the power minus x, where e is the Euler's constant. For example, if you want to calculate the hyperbolic function like sine hyperbolic x, so it can be written as e to the power x minus e to the power minus x by 2. And we can also write for the cos hyperbolic, that is e to the power x plus e to the power minus x by 2. Okay, so somehow what they are similar to the trigonometric functions, but yes, they are defined in the terms of algebraic expressions. Okay, so NumPy also provides the universal functions like sine hyperbolic, cos hyperbolic, tan hyperbolic, which take the values in the radians and produce the corresponding results for them. Okay, so let's consider a code and then we will understand how it performs the function. Okay, so we need to calculate the sine hyperbolic value of pi by 2. So here it is. Import NumPy as np, x equal to np dot sine hyperbolic. We are taking the argument as np dot pi by 2. Okay, so we are calculating the value of pi by 2 for sine hyperbolic and we are printing its result. So let's save this code and run this code. Okay, so here it is. It's 2.3. Now similarly, if we want to calculate the values for all the values in an array, so let's this time consider the cos hyperbolic. Okay, and we will just implement a code. Okay, so here it is. We are considering an array of radians here, and then we are calculating the cos hyperbolic value of it Okay, so here it is. Okay, so import NumPy as NP. ARR equal to NP dot array, NP dot pi by 2, pi by 3, pi by 4, pi by 5. So we are taking the radian values here. Okay, in the form of an array, and then we are giving this array as an argument to cos hyperbolic. X equal to NP dot cos hyperbolic ARR, and then we are printing the value of x. So let's save this code and run this code. So here it is. These are respectively the values. Okay. Now if we need to find the angles. So for finding the angle values of hyperbolic of for example sine, cos and tan, we are having sine hyperbolic, cos hyperbolic and tan hyperbolic inverse. Okay, as we are having for the trigonometric values. Okay, so the NumPy provides universal functions, that is arc sine hyperbolic, arc cos hyperbolic and arc tan hyperbolic, that produce the radian values corresponding to them. Okay, so let's consider a code and then we will understand. Okay, so here it is. We need to find the angle of 1. Okay, so how to calculate the angle? It's like this. Import NumPy as NP. X equal to NP dot arc sine hyperbolic 1. Okay, so we are using inverse of hyperbolic sine here, and we are putting the value 1 as an argument, and then we are trying to calculate the angle. Okay, so we are printing the value of x by it. So here it is. Save this code, run this code. 0.88. Okay, this is the angle. Alright, now if you want to calculate the angle of each value in an array, that means here we are giving an array as an argument. So let's consider one more code. Okay, and we need to calculate for the tan hyperbolic. Okay, so here it is. Alright, so import NumPy as NP, ARR equal to NP dot array, and this array we are giving as an argument to tan hyperbolic, that is arc tan hyperbolics, or we can say that it's an inverse of tan hyperbolic. Okay, and then we are printing its value. Okay, so let's save this code and run this code. So here it is. This is the output. Okay, for these respective values. So that's all about the trigonometric and hyperbolic functions in NumPy. We'll come up with more exciting lectures. Thanks for watching and kindly do subscribe to my channel.